record, you know, because my camera now will be facing the ceiling, right? You won't be seeing me. So let me take the blue color, my styler, and where is my printout? Here. So this is section 1.3. Two more examples. Two more examples. Okay, they are special cases. So they are special cases. Special cases. Okay, and once again, always keep your notebook nearby, because you know you should be using it. You should put all those examples into it, because you don't want to rewatch the video if you already worked on it, right? So number one, we are trying to solve this equation: 3x minus parenthesis x minus 3, and then equals to 2 parenthesis x plus 1 closing parenthesis plus 2. So this is number one, and this is number two. Solve. And this one, 3 parenthesis x minus 1 equals to 3x minus 5 plus 2. Okay, so I'll give you 3 minutes to start working on them, and I'll go grab my cell phone because I forgot it and I need it for timer. Start working on them. You will be getting weird stuff. Don't be surprised. Just keep it as is. See what you're getting at the end, right? And then I will talk about it. Okay, so I'll go grab my cell phone. Just give me a moment. But you start working on them, okay? Oh, and I'll pause the recording. So I'm resuming the recording, checking chat messages, okay. And let's talk about them. So for what I would do for this first one is I would open up these parentheses first, and be careful because this negative will be introduced inside it, right? So it will be like I'm multiplying x by a -1, and I'm multiplying -3 by a -1, right? So this gives me, let me change the color, 3x minus x plus 3, right? So this minus is affecting both the x and the -3, right? So this is the first step, and let me mute my phone, okay, because it's making sounds. Now, so negative attached to x would be -x, and negative times negative will be positive, right? Okay, now on the other side, I'm going to use the distributive property, right? So 2 times x and 2 times 1, right? Now, for that one, what I will be getting, yes, so Lane got 2 equals to 1. Okay, yes, so let's see what I will get. So 2 times x will be 2x. And then 2 times 1 will be plus 2. And then 2 times 2, oh no, 2 times 2, just the 2, plus 2. Okay, got this one. Okay, so 2 times x is 2x, 2 times 1 is 2. I almost tried to multiply 2 by this 2, but then I said, oh my God, what am I doing, right? So no, plus 2. Now we combine like terms on each of the sides separately. So for example, here, this one and this one are 2 like terms. 3x minus x will be 2x plus 3. Now, this one doesn't have a like term for it, so I'll just copy it over. But these two, check them out. 2 plus 2 gives me 4. Okay, so then we follow the strategy of collecting all the x's on one side. But guess what? Do you see that this 2x is absolutely the same as this 2x, right? So no matter where you send it, whether you would send this 2x to the left or this 2x to the left, it doesn't matter. We are doing minus 2x, and our x's disappear, right? So those special cases, both of them, the number 2 will be very similar, are about the cases when the x disappears, when the variable gets absolutely canceled, right? So what I'm left with then is only this 3 is equal to the 4, right? Okay, so I'm getting something different from Lane, right? Like take a look at what you got. Probably there is some computational mistake there, because the other thing you could get is you could subtract 3 from both sides. You know, it's just I'm thinking of what could else we do, like minus 3, and get something like color. 0 is equal to 1. So this one you could get, or this one you could get, or you could subtract 4 from both sides and get something like -1 is equal to 0. So these combinations, any of them, it doesn't matter which one you get, right? But any of these combinations is false, right? In other words, 3 is not equal to 4. That's not true, right? Or this one, or this one. So they are all false, right? And got, okay, you added, yes, I see how. Okay, yeah, got it. It's good that you found it. Okay, um so what I want to say is any of these statements, because equations are statements, right, are false. Let me put it up. False. False, right? Now, what it means is that no matter what value for x I use in this equation, it will not give me a solution. It will never be a true statement. This is the case when the equation doesn't have any solutions, and we will say no solutions. Okay, no solutions. So when we get the statement which is false, right, while we are solving the equation, this equation does not have any solutions, right? Now, there might be another case, right? We were solving it, x was completely disappearing, but instead of this false statements, we're getting something true, like this one, right? A true statement, 0 is equal to 0, or 4 is equal to 4, or 3 is equal to 3. This is different, right, from this false case, because it means that this equation is always true. No matter what value for x I would use, it will always be giving me the true, right? But let's solve it, because it's, once again, it's practice for us in solving equations, and you will see how do we end up with this 0 equals to 0, right? So same thing here. We distribute, right, the 3, the multiplication by 3. 3 times x equals to 3x. 3 times -1 would be -3, right? So I opened up the parenthesis. Now on the other side, what I will do is I will combine these two like terms, because they are like terms, right? Minus -5 plus 2. Okay, so we're getting 3x minus 2. And same thing here. What I will be looking for is to collect those x's on one side, and it will be absolutely the same situation here, right? No matter where I move the 3x, I will be doing -3x minus 3x. It will disappear. Oi, you know what? I see my mistake here. Why nobody corrected me? -5 plus 2 would be -3, right? This one. This one I made a mistake with, right? -5 plus 2 would be -3, because I'm looking at the equation and I see, oh my God, I'm getting the false one, right? And I shouldn't, okay? So from this one, I put the wrong number here, right? It should be -3. Okay. Okay, so once again, the x disappears. We are left with the -3 equals to the -3. So I'm getting the statement that the -3 is -3. What I can also do is I can add the 3 to both sides. So here, say +3 plus 3, and it will give me the statement 0 is equal to 0, right? Exactly what I'm aiming at here. This statement is true. So this one is true. This one was true, right? All of these statements are true. So I could actually stop right here without any additions of 3 and say, hey, this equation is always true. We call it identity, right? And it means that any x will do, any value of x will do. So that's why in this case, we will put as the answer, let me close the chat window because now it's on my way. Okay, we will say infinitely many Okay. Solutions. Infinitely many solutions. So this will be our answer for this equation. And this will be our answer for the first equation. So now, do you remember what the infinitely means, right? Then it means that we can never stop, right? So for example, if we talk about the counting numbers, it's like, 0, 1, 2, 3, we say that there are infinitely many of them, right? If we talk about the whole numbers that include the 0, 2, or even the integers, right? So we include the negative ones as well. We say there are infinitely many integer values, right? So infinity means that there are many, many, many of them, right? And we can never stop. So that's exactly the case, right? This equation, any value is a solution for it. Just imagine using 0 for x, right? Just imagine it. Let me show it. Just imagine that I'm having 0 here, 0 here, 0 here, right? 0 minus 1 is -1. -1 times 3 is -3, right? Now over here, 3 times 0 is 0. -5 plus 2 is -3. So we're getting -3 is equal to -3. And this will happen with any value I would use for x. 5, 10, -1 million, right? 2.7, and so forth. Any number, any real number we say, because we're dealing with real numbers, right? So any real number will be a solution to this inequality. That's why, since we cannot list them, and we cannot list them, right? We say just infinitely many solutions. So 2 of the exercises in your homework were about these 2 special cases. So in that homework number 2, you will see 2 problems that will be dealing with these special cases. The third one might look like it, but I think it has some number as the answer. The only thing is, like, I cannot predict it 100% because it generates different numbers every time. But I remember that the goal of those exercises was that one of them has no solution, one of them has infinitely many solutions, and one of them, has some numbers. So let me show you the ones that I'm talking about. But in a moment, before I proceed, because everything will disappear from the whiteboard, let me know if you have any questions about these 2 particular special cases. Mm-hmm. Let me check the chat messages. No questions? Okay. Mm-hmm. Okay, so let me show you those 2 problems from the homework assignment that I was talking about. I'll share. Always need to move the tools around. I'll share our web page, but I will go to our homeworks sets. So it's the homework number 2, and I think I'll find them because I'll have to go through them. Probably somebody is giving me here. You see this one? So problem number 9 and then problem number 10, it must be the case. Okay. So, okay. Let me just answer the chat message. Mm-hmm. Okay, so number 9, number 10, I remember, and I think one of them has a solution. So, there is no issue there. But once again, since they are automatically generated, right, they might use different numbers. So maybe you will get another one with no solution or with the other. So this one, the infinitely many solutions, this is also the replacement for it. All real numbers are solutions, right? And I think it's actually probably even sounds better than infinitely many solutions, right? So you would say all real numbers are solutions, okay? Okay, so yeah, this was about this. So once again, about the questions with the fractions, these are the ones that I wanted to cover with you. This is what the topic when it goes deeper, right? So we go a little bit, we dive a little bit deeper with the fractions. We need to see how to work with them. And then I posted the solutions of my practice problems on the web, right, on our web page. You will find them there. And yes, the Khan Academy, you'll just be looking for it. I didn't just tell number 12. Yes, so in the number 12, the first thing you do is you find the LCD for the fractions, right? Remember when we were playing with the fractions and you find the LCD for it? So you find what the LCD for it. For example, here, I think it's 36, right? And then the idea there is to multiply this time of the equation by 36 and this time of the equation by 36. Then you will be using the distributive property, simplifying and simplifying fractions. So it all goes back to fractions. And here is the hint. The goal here is to get rid of all these denominators. So after you do that multiplication and simplify, you should no longer see the denominators. You should get a regular, equation with the whole numbers or with the integer numbers. Okay. Now, if you do not remember how to multiply fractions, right? I gave you the link to the material on our website here. It's the first meeting we had, right? So this is the source for you to refresh the fractions, like how to simplify them, how to multiply a fraction by a whole number, and so forth, right? But if it's not the issue, right? If you remember pretty well, what do you do? So then you just multiply both sides by 36. Okay, yeah. No, you don't multiply twice on one side. So this is a warning to everybody.
No, that's the thing. Because when I entered it, it wasn't accepting only 36. Like it had 36 on one side and then 36 on the other side in the first column.
Exactly. So this is what
And
you will
then
be seeing.
in the second one, it has like the equation, but you have to multiply also by 36. So one side has twice 36, and then the other one has once times 36.
Okay, so what you can say is you have two appearances of 36 on the left side, but you cannot say that you're multiplying the left side twice. Okay, so that's why I didn't like it, like how it said. So yes, you could say that you have two 36s, and this comes from the distributive property, right? So you multiply this one by 36 and you multiply this by 36, right? But the left side was multiplied only once. This is what I was scared about. Okay, so yes, I now understand what you meant. Okay, yes, exactly. So the idea is when we multiply the complete entire side by a number, it means that we'll have to use that distributive property there, right? So when we use that distributive property, then it will help us, right? So over here, it will be like 36 times negative 7x over 12, and then plus 36 times 5 over 9, right? Let me close the chat window. And then it's equal to 1 over 18. And remember, 36 over 1, right? This is how we can rewrite all the whole numbers as over 1. I think this will give you a hint on how to proceed next, right? So this is one way of solving the equations with the fractions. I did say it's like the straightforward one. But in some examples, you might see that you won't have to use this kind of heavy weaponry, right? We could just move x's to one side and constants to the other side. And sometimes like some of the fractions will disappear, or they will be easy to finish by multiplying both sides by reciprocal. Okay, so once again, two methods usually, this one that we have here or the other one. The other one I definitely show it in when I was solving the practice problems. So you can, you will locate it. Anyway, this method will also always work. Don't worry about it if you don't want to go to my notes, right, and see that. This method will always work. Don't worry about that one. If you don't want to spend your time on, I'm not saying lose, okay, spend your time on learning that extra method. Okay, so you can just stick to this one if you don't want to. Okay, Okay, let me clear all my drawings, right? So the rest of the problems in this homework, which will be due Wednesday, right? So you still have time to work on it, and I really wanted to look at it. The rest of the problems, 12 through 16, is about, oh no, not the rest, only through 12 through 13. Okay, so few of them are about the fractions, and then the rest, as you could see, the little equations, right? And I posted a little bit of more of the practice also on our website in that practice that we didn't finish, right? Last time on Wednesday. Okay, so let me go back to our whiteboard and let's practice for the material that you were covering. Oh, it kept all my writings. It's so good. They probably did the update and now it keeps everything. Wonderful, 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 because, you know, sometimes I really needed it. And last semester when I was using it, it was erasing everything. Okay, now, so I would like us to practice for these sections, and I'll type it in, sections 2.1 through 2.3 for the inequalities. And you will see that there is a lot of common between equalities and equations and inequalities, with too few exceptions that I will point out to you. So the first two questions, okay, number one, choose the graph that represents, and we will have two of the items, okay, A and B. So this is A and this is B. Each item will have its own set of pictures. So A is less than 7, and over here I'll have to type it in, X, and then I will have to draw it. So oops, why did it? I apologize. It removed all my spaces, although it shouldn't. Okay. I'll add the spaces up. Okay. So the tabulations didn't work for me. I had to put the spaces. Okay, got the right color. So, and then this one. Greater than or equal to 1 over 2. Okay, so what I'm going to do is to do the graphs, 4 graphs for each all the options. So this is option 1, this is option 2, this is option 3, and this is option 4. Okay, let me find my half over here, my half over here, my half over here, and my half over here. Now I'm graphing it. So here is what I do. I do like this and I go to the right. Or over here, I do like this and I go to the left. And now I do this, shaded and go to the right. And then here, shaded and then go to the left. So now what I need to do is I need to pick only one graph because only one is correct. That would represent this inequality. This X is greater than or equal than a half, right? I'll do the same for B. And while I'm doing the graph for B, look at the graph for A, okay? Okay, 1, 2, 3, and 4. Okay, so here is the 7. And here I go, similar way. I need another color. Oh, like this. Oh, like that. Oh, like this. And like, okay. Now, if you did not have the Zai books, right, so you were not able to go over the topics, then just, you know, bear with me, wait for my explanations. You will actually grab it pretty fast. It's not something complicated. Don't worry. So let's vote. For number A, what do you think the answer is? You can either speak up or you can put your answer into the chat messages. Okay, so it's, once again, I'm not, you know, grading it. It's just your opinion. I want to know, what do you think about them? I'm moving my whiteboard a little bit. Okay, so for the item number A, right, what do you think it is? Mhm. I'm getting the answers. You know, I probably should do the poll, but I find out that the poll takes time to do. So, you know, I'll try to see if I can do the poll fast. Three. I'm getting a lot of the options for the item 3, right? And I agree with you. Yes, I agree. I absolutely agree with you. The answer there will be the 3. So this is the correct graph. Let's see why. This arrow over here tells me that I should take every single number over here to the right of a half. And this is exactly what it says. X is greater, right? X is greater, greater than or equal to 1 over 2, right? So that's exactly greater than, right? Now, how do we show the equal? We shade the circle, right? So if the circle is unshaded, it means that I'm not taking it, right? I'm not taking that number. But if it is shaded, it means that I'm taking it. So the shading stands for the equal, right? And then this arrow, right, usually stands for the greater than, right? Greater. So if it is greater, we go to the right. If it is less, then we go to the left, right? So this one, for example, says A is less than 7, right? Kariman didn't check yet anything because didn't have an opportunity. So when you will be working on a problem, like I'll put something to work on, I'll check your scores. So now let's do another poll, and I know that some already began to answer. Which do you think graph represents this inequality, right? Okay. I'm seeing number 2, right? In the answers. Number 2. Let's see. Okay, less than, it means less than 7, right? So to the left of it, the number line shows us numbers not order it, right? So if I do the number line here and I put a 0 here, I cannot put -1 here. No way, right? The -1 should be over here, and this one would be +1, right? And so forth. So the numbers grow from left to the right, right? So we go like that. From left to the right, they do grow. Sorry, I reached the ceiling of the whiteboard there. Right. 7 and 4. Right. Now, 7 and 4, 7 and 4. Okay. Now, it doesn't say that it can be equal to it, right? So I don't have this sign over here. So it means that it must be strictly less, right? Strictly less than 7. So what it means then is I have to exclude the 7. That's why the 2 is the correct answer for it, right? So that's why not the 4, because it is including 7, right? And I need to exclude it. So I need that empty circle, not the shaded one, right? So that's why the answer will be the item 2. Okay. Now, why did you need all of this? Because it was in the first section, right? 2.1. And the reason of why we do this is when we usually solve inequalities, we get at the end something like this, simplified, either this, or this, or something else, very simple. X on one side or Y on one side, doesn't matter, variable on the left side. We prefer it to be on the left side. So this is what differentiates us from the equations, right? In the equations at the end, we can switch the sides. We cannot do so in inequalities for free, right? So we, from the very beginning, when we are solving inequalities, we'll always keep the variable on the left side. Yes, if you ask me, yes, it's possible to have it on the right side. At the end, we'll have to rephrase the answer, right? But usually, as a rule of thumb, we keep the variable on the left side. So this is the first difference between the equations and the inequalities. The second one I'll show you later on in the examples. So let's see other examples. Now, in these two, you will be asked to solve the inequalities. So solve the inequalities and graph their solutions. So this is the idea. We already know how to graph everything, right? We already know how to graph everything. Now, in addition to that, we will be first solving inequality and then graphing its solution. So I have item A here, and I will have the item B here. Now I'm using the spaces so that it will keep the distance between them. Now, the first one, where is my inequality? Here, it says 3x minus 7x minus 28. And the next one, 9, parenthesis. So this is 9. The G looks like this when I usually write it. X plus 3 greater than or equal than 4x minus 3. Now, when you will be solving, and I'll give you 4 minutes to do so, when you will be solving this first inequality, the strategy is to keep the variable on the left side. And then what you will have to do at the end is you will be dividing by a negative number. When we divide by the negative number, this direction on the inequality will change to the opposite one, right? So you will have the situation over here. You will not run into the change of the direction here. I on purpose put two of the problems that are similar. You'll be using the same strategy, but in one of them, you'll have to reverse the direction of inequality. And in the other one, you will not. Okay, now, usually the strategy is right? Collect variables on the left side, right? So we do move the constants similar to what we did before. We do move the variables similar to what we did before, like the terms, right? Everything is the same. It's just this, the goal is changing slightly. Okay, collect variables on the left side and then get rid of the coefficient, constants first, then the coefficients. Okay, so I'll give you 4 minutes to work on two of these, and then I will work on them myself. So now, once again, if you didn't have the Zai books and if you didn't cover it there, right, then just try it on your own, right? Maybe you remember the stuff, maybe you did it before, and if not, just wait for 4 minutes and then I will also work on it, okay? So I'm going to recording. Okay, got it. So for the first one, the answer will be x is greater than 7. And we'll do the graph later on, right? But this is the answer when I solve it. Now for the second one, you will be getting that the x is greater than or equal to -6, I believe, right? Now check this out. This inequality symbol didn't change its direction, but this one did, right? So this was less than, now this one is greater than. Okay, so it happened because I had a division by a negative number. The same would happen if I have a multiplication by a negative number. So only two cases when the direction changes. I either multiplied by a negative number or I divided by a negative number, right? So if it was not a negative number, then the direction will not change. Okay, now let me work on it. And if you didn't get those answers, then you will see how to get them, all right? First thing I will do is I will move the 7x to the other side. So I will say minus 7x minus 7x. What happens here is that they get canceled, right? Because 7x minus 7x will be 0. Now, over here, 3 minus 7 will give me negative 4x. Negative 4x, right? So this is from here. 3x minus 7x. And then I will say less than, and then I have this one in place, right? Negative 28. So now from here, what I'm going to do is I need to get rid, or let me pick the, of this coefficient, right? I picked the yellow one. So I need to get rid of this coefficient, and it's a times here, right? So remember what we used to do with equations? We divide it by -4. Same we'll do here. -4 dividing by -4, right? Now, this is the place where the direction of the inequality will change because we are dividing by a negative number, right? So these two will cancel, we'll get x, and then negative by negative will be positive, and 28 divided by 4 is 7. That's how we got our answer, and then we will graph it. Now, the funny thing about these inequalities is that you don't need to put the scale. All you do is you just draw the 7, right? You see, what is it? It's a strict inequality, so I should do a circle, right? And then it says that x is greater than 7, so it should be to the right of 7. So I will do it like this, right? And if we want to use another color to make sure that we understand it, we do it like this. So this arrow means that we go to the infinity, right? To those positive infinite numbers. Positive infinity. I think it would be better to say positive infinity. Why did you flip the sign? Okay, so once again, we flip the direction of the sign when we divide or multiply by a negative number. Okay, so only in these situations, we divide it by a negative number, I have to change the direction, right? Now, where does the idea come from? Where, like why, right? Why does it happen? Just think about it. Let me put up it. Negative 4x is less than negative 28. Try to find a number which will, make it true, right? Which will make it true. Which x will satisfy to this inequality? Well, how about the 5, right? So x is 5. If x is equal to 5, then negative 4 times 5 will be negative 20. No, not good. I need to pick something else. How about x equal to 10? I think it will be better, right? X equals to 10. Okay, so then 4 multiplied by 10 with the negative will be negative 40. This one is better because negative 40 is indeed less than negative 28, right? Do you see that this 10 is exactly from this interval when x is greater than 7, right? So it's kind of vice versa. If I were to keep that sign, then I would say that x to be less than 7. But 10 is not less than 7, it's greater, right? So what I mean sometimes is it's good to see by the example, right? It doesn't prove anything, no. The proof, we can talk about the proof and we can present it, right? But on the second one, okay, okay. But the proof usually takes some time. It's really fast to play with the number, right? To see, hey, it's indeed so. Okay, so let me erase these ones because it's just a comment and I don't want to use the space on the whiteboard because I need to solve the second one, right? Okay, let me close the chat window because I need the space. So let's go ahead with the second one. 9 times x will give me 9x, right? 9x. 9 times 3 will give me 27. And then over here, it will be 4x minus 3 copied over. Now, we are going to move the 4x to the left side. So once again, in inequalities, what we tend to do is we move the terms with the variables to the left side, okay? So now from here, I will be getting positive, right? 5x, because 9 minus 4 is positive, 5x. 27 is copied over. On this side, the 4x is gone. We are left with a negative 3. So it's like our equation that we used to solve. First, we would get rid of this 27. We will send it to the other side, right? So we will do minus 27, minus 27. These two, negative 3 plus negative 27, will give me negative 30, right? And then on this side, I have 5x only because these two got canceled, right? The 27 was moved. Okay, so then the final step here would be to get rid of this multiplication by 5, right? So in this way, I divide both sides by 5, and guess what? It's a positive number. The direction of the inequality will not change. So we will get x is greater than or equal to negative 6. Right, so this will be our answer. And let's do the graph. So this is the number line. This is the negative 6. X should be greater it or equal. So this equal will make the circle shaded, right? So negative 6 is good as well. And then we show the arrow to the right, right? This will be the answer for the item B. Let me know if you have any questions. Recording, okay? So for the next two. So we get this one. Negative 46 is less than negative 4 plus 7 times x minus 3, and it's less than negative 11. Now, the ones that you saw in the Zai books were really, really simple, like, you know, one or two things to do, right? But this one, you will see that we will be working and working and working on it. Still, it's not complicated. And keep in mind, we'll be only concentrated on this part. Now, the second one, 2x plus 7 is less than 21. Or, oh, I have or here. Okay, or x minus 3 is less than or equal to negative 5. And I have a typo in my note because it should be or. Okay, I'll correct it. So when I post the document online, right, with these questions, you will see the correct one. Now, what I will do here is just the moment for you to think, you know, maybe like a few seconds. What will you do first here? Because I want to work on it together with you in parallel, right? So I'll be kind of guiding you here. So first thing to do is look at this middle. What it says is that it's guarded on both sides. It should be greater than negative 46 and it should be less than negative 11, right? So this expression over here is a value between the negative 46 and negative 11. When we solve this type of inequalities, what we do is we unwrap the things over here. We have parentheses, open them up. If we have constants, move them on both sides, right? Both sides, they do travel to both sides, okay? And then finally, we'll be getting rid of the coefficient. So the first suggestion I would do is look at this middle, use the distributive property to open the parentheses, and then combine like terms. So work only on the middle, okay? I'll rewrite the left sides meanwhile. Negative 46, not the left sides, but both sides. And then negative 11. Okay, so take your time to work on the middle. And let's see what you're getting there. Don't put it into the chat messages. I know that it takes time. But so 2 steps. Open up parentheses, combine like terms. Okay, so this is what I'm getting. I am getting 7x minus, it would be minus, I think, okay, 7 times 3, 21, plus 4, okay, minus 25. This is what I'm getting, right? Let me know if you don't see how did I get it, right? But I'm getting 7x minus 25. Everybody's good? Okay, excellent. Let me see. Let me check the chat messages. I'll put them up. Okay, so I have a question. So let me do it over here. We do -4 plus 7 times x gives me 7x. And then plus, right? And then I multiply 7 times -3 plus -21. And if you combine these two, that's how you get the -25. But that's how I get the -25, and that's how you get the -25. Okay? So 2 steps, right? 2 steps we did. Okay, now the next step for us will be to look at this constant. It's a constant, and get rid of it. Now, what do I mean this time? I need to send it to both sides, to the left and to the right. So I will do plus 25, plus 25, and then plus 25. So right now we have 3 parts in the inequality. And whenever I do an operation to one part, I need to do it to 2 others, right? So this is what it is based on. That's why we are sending it to both sides, to the left and to the right. So we add 25 to all the 3 parts of the inequality, right? And you see that it will get canceled here, right? So work on the right side and work on the left side. See what numbers are you getting? I'm getting 14 on the right, positive 14, right? Because it's a -11 plus positive 25, right? It's the same as 25 minus 11. And then here, it's -46 plus positive 25. We have to subtract 46 minus 25 will be what, 21. And I keep the sign of the -46, right? This one. So this is what I am getting, right? After I do those 2 operations. Now, what do you think will be the last step? Just think about it for a moment. What do you think should be the next and the last step, right? Divide by 7. Check this one out. You see that I have a multiplication here. So for me to isolate the x, I need to divide this by 7 so that it will cancel. And I have to do it to all 3 sides. So this one, divide by 7. This one, divide by 7. This will be our last step. Okay. While you're working on it, I'll erase this, because I need space for the number line. So this is what we are getting. -3 x and then 2. So the x is between the -3 and 2, right? And for this statement, I have the word and. X is greater than -3. That's me rephrasing this part. And x is less than 2, right? So I have the and word there. Now, if I were to draw it, it's actually really, really, really simple. This is the -3. This is the 2. The inequality is strict circle, circle, and x is in between. Let me do it. This, and x is in between. So I would shade everything in between the -3 and 2. Any value satisfies to the inequality should be between -3 and +2. Let me know if you have any questions. Everybody's good? Okay. So now let's look at the last one for the practice, and then we'll have our Kahoot quiz, okay? The last one is having this word or. Or means that x is either in that interval or in that interval, like one or the other, right? So what it most likely means is that it will not be in between the 2 values, but it will be outside them, as you will see. So I will solve this one separately. I will solve this one separately, and then I will join those results, right? Since we already solved it, just a moment for you to think, what would you do with the first one? What would you do with the second one? And then I will also work on them. okay? Or I work on them silently and you work in parallel with me. Just few moments, you know, few seconds, and I will begin working on them. I'll just show you my first steps, what I am thinking of. Yep, Tiana, I agree. Yeah, I agree with the left one. For the second one, we get the answer right away after we move the 3, right? What is it? -2. Okay. So this I already finished with, right? But this one, yeah, I agree with you. But this one I have to do one more step. Tian already did it. So as many of you, right? So this is cancels and x is less than 14. Isn't it weird, right? Like, you know, the equation is weird. I'll show you the number line, right? Wait, 14. Why did I put the 14? 7, right? 7 here, 7 here. Okay, so on the one side, I'm getting that x is a less than or equal to -2. Let me put the or, right? So this one or that one, because it's you know, it's kind of weird. So let's check it out. This is the -2 and this is the 7, right? Now the first one tells me that it's not the 7 and it's everything to the left. The second one tells me that x is less than or equal to -2. It's from here to the left, right? So, you know, both, like the intervals are overlapping, right? You notice that they overlap. So this interval overlaps with this interval, right? So what we can do in this case is we can just give only one solution, right? Only one answer. So answer like that for this case. We will have that the x is less than the 7. That's it, right? Because the intervals did overlap, so it happens so that, you know, we will have only one interval. It's this one. Okay, it happens. It's a nice example. I grabbed it without even thinking. And I've got this like weird answer, but it does happen. It does happen usually when I see the word or, right? The examples that you probably saw with 2 intervals, right? 2 intervals. But in this case, we just ended up with one, that the x is less than the 7. Okay, let me know if you have any questions about this one. And I will stop the recording.